Hello everyone. It's the time for testing our model. What we have done till now is connecting this servo motor, micro servo motor, to the Raspberry Pi 5. And let me show it to you. This is the mic that I will use to give the order for the model to predict. And this is the entire kit actually. This is the Raspberry Pi with the uh, USB mic connected to my t-shirt, and these the pins that we are used to connect to the servo motor, and this is the power bank charging the Raspberry Pi. So what we're gonna do now, step number one, is to make this work. Actually, I copy a code from the Google for moving this plastic arm of the servo. Thank you for the person who create this function. I don't know who is the person. So let us test this function first. So I will create a function. I will call it servo motor. And I will bring my code from here. Right click copy. So this is the function actually. Control V. If you are using Raspberry Pi 5, you need to install this library for the purpose of activating the GPIO. If you are using Raspberry Pi 4, you need to install this library for the activating of GPIO. We are using GPIO 18 for the purpose of the movement or prediction of the servo motor. What else? That's it. GPIO 18, it means that pin 12 in the Raspberry Pi. So let me call this function. I will call this function now. And I will just for a while disable the other functions. I don't want the other functions to work. So I will disable these two functions for now. Control S. And I already have activating the environment in the terminal. So Python up.py test the servo motor working properly. So the next step, I will remove the call of the function from the main program, Control X, and I will hide the servo motor function. Servo motor function is working properly, and I will use this function on the prediction after the prediction area of the function called audio prediction. So this is actually these two functions we have tested before. So now, if the prediction more than 0.9, call the servo. So this is what we're gonna do. So servo area, if prediction more than 0.9. This 0.9 is a threshold you can tune with, you can play with. It depends on your scenario and environment. So now you can call the function and let as the servo work if only if the prediction was more than 0.9. So let us test this function. This function actually containing the audio function inside. This is the audio function, as you know. Oh no, this function is alone and the audio function is alone. So you need to call them both. You can put the audio function here inside the audio prediction as you like. It's just I want to make it simple. So Control S, everything is fine. Go to the environment and call. Not working, that makes sense. It's not, the prediction value is 0.02, which is not greater than 0.9. Control L. Ahmed, it's working. It's working. It's working properly. It depends on, so let me add some noise for the environment so that it's not a silent environment. Control L first. Call the function. Sorry. Python Python upload noise. It's not working. Even there is a noise outside, but there is no detection of the word Ahmed. Control L. Ahmed. So even in case of noise, look at look at the prediction value. It was very high. I think that I think that make our model robust enough. We can do more further testing actually, if we have time. Yes, I have some few minutes. Let us do some kind of. I will add a loop. So let me go for j equals 0 while j less than 5. Okay, call these two functions control indent and add j plus equal 1, and I think time dot sleep for 2 seconds, so that give time for the loop. Control S. Maybe we need to import time. Import time. Control S. And let us test this scenario. So for several times we can inspect our models working to check the how robust is our model. Python.app. Go. Ahmed. Ahmed. I think it's really strong, robust audio classification model. I'm really happy and delighted we reached this point. Thank you. See you. I don't know. See you next video. Thank you.